Hey everyone, welcome to 3.1 and first section in chapter 3. We're going to continue with derivatives and we're going to restart with the chain rule. This is why this is a separate chapter. From here on out, pretty much every derivative will be a chain rule problem. So what does that mean? Well, let's take a look at it. What if I ask you to find the derivative of this problem? Well, you can't right now because there's an inside part of this and an outside part of this. So what you could do is write this thing out 7 times, multiply it all the way out, and then just take the derivative of each section. That's how we would have to do it, but I don't want to have to multiply 7 times. So we're going to do the chain rule. The chain rule, I like to think of it as the outside-inside rule. We're going to deal with composite functions. Those are things that have outsides and insides. It's one function inside of another function. What do? We do the power rule like we normally would do. So we take care of the outside part first, and then we take care of the derivative of the inside part. Take a look at this example. X squared plus 1 cubed. Well, let's take care of the outside, the cubed part first. We pull the 3 in front, we make the 2 there, and we leave the inside b. This is really important. When you do the chain rule, you work outside first and leave the inside b. And then you take the derivative of the inside. The next step is just cleaning it up. 3 times 2x is 6x, and the inside is x squared plus 1 quantity squared. Take a look at this problem. The first thing I would do is rewrite it as 4x squared minus 1 to the 1/2. It's a chain rule problem because there's an outside and there's an inside. So I take care of the outside first, put a 1/2 here, negative 1/2 is my new power. The inside stays the same. Now I take the derivative of the inside, which is 8x. And the last step is just cleaning it up. 1/2 of 8x is 4x. This is on the bottom because it's negative, and a 1/2 makes it a square root. Work outside, inside. When you do the outside part, leave the inside b. Okay, let's try a couple. This is a chain rule problem. Why is it a chain rule problem? Because there's an outside function of a 4th power and an inside function of 5x squared plus 3. Let's take care of the outside function first. The outside function is a 4th power, so it's 4, and the new power is going to be 3. Leave the inside b when you do this. So I've taken care of the outside part. Don't forget, now you have to do the derivative of the inside. What is the derivative of 5x squared plus 3? It's 10x. That's the chain rule. We work the outside function first and leave the inside function b, and then we take the derivative of the inside function. Don't leave the answer like this. Clean it up. That's 40x, 5x squared plus 3, quantity cubed. Work outside in. Leave the inside function b when you work with the outside function. Let's take a look at this one. This problem is much easier if you rewrite it first. So I'm going to rewrite this as 7x squared plus x to the 1/3 power. Now it's pretty easy to see that there's an outside function of 1/3 and an inside function of 7x squared plus x. So let's take the derivative of the outside function. Put the 1/3 in front, leave the inside b. And what's my new power? Well, the power rule says subtract 1. Well, 1/3 minus 1 is negative 2/3. I took care of the outside power. Now let's do the derivative of the inside. A lot of people will make a mistake here. What's the derivative of the inside? It's 14x plus, what's the derivative of plain x? 1. Cleaning up my answer. So y prime equals 1/3, the 14x plus 1 stays on top, and the 7x squared plus x to the 2/3 goes on bottom because it was negative. And that is your answer. Chain rule. Outside first, leave the inside be, then do the derivative of the inside. Okay? Some problems are chain rule problems and some are not. For example, this is not a chain rule problem. There's not one function inside of another one. This one, though, is. Let's talk about this function. What's the outside part of this function? Sine. What's the inside of this function? 6x. Well, let's take the derivative of it. Work outside first. Derivative of sine is cosine, and leave the inside b. Times, what's the derivative of the inside of 6x? It's 6. Clean that up a little bit. That's 6 cosine 6x. What about this function? Is this a chain rule? Yes, it is. There's an outside and an inside. The outside part is the 5, so we'll take care of it first and leave the inside be, times the derivative of the inside. The derivative of the inside is just 3. Clean it up. And there's your answer. By the way, this very first problem, what's the derivative of x squared plus 5? It's just 2x. What about this problem? Is this a chain rule problem? Yes. Let's rewrite the problem to make it a little bit easier. Let's call it x squared plus 5 to the 1/2 power. Now, the outside is the 1/2 power. The inside is x squared plus 5. Outside, I get the 1/2. The inside stays the same. Times negative, or to the negative 1/2. If you subtract 1 from 1/2, you get negative 1/2. Times the derivative of the inside, which is 2x. Cleaning this up, the 2 and the 1/2 are going to cancel out, so I'm just left with x. This will go on bottom as a square root, x squared plus 5. How about the next problem, 3x plus 2? Is that a chain rule problem? No, it's not. Because there's no outside and inside function. It's just 3x plus 2. Y prime equals 3. How about the last one, y equals sine x? Is this a chain problem, chain rule? No. There is no outside and inside function. What's the derivative of sine x? Cosine x. So be aware of that. Sometimes there's an inside, outside, and sometimes there's not. Don't forget your derivative rules. Okay. Product rule, because there's two functions, with chain rule, because there's an outside, inside. This is what you guys did a lot last year with Miss Baer. This is called chain rule factoring. I have an entire mini lesson dedicated to this because it's so important. So if you have some trouble with this, check out the mini lessons on YouTube to get more practice with it. As always, we'll do more practice in class. Why is this a product rule? Because there's two things. Why is there a chain rule? Well, this one isn't, but this one is. It's got an outside and an inside. First of all, let's rewrite the problem as x squared, 1 minus x squared to the 1/2. Okay? I'm going to do the first in blue and the second in red. Product rule says f prime equals first, derivative second. But when I do the derivative of this thing, it's a chain rule problem. 1/2, inside stays the same, negative 1/2, times the derivative of the inside. Be very careful. What's the derivative of the inside? It's negative 2x. Plus the second. No chain rule here, I just write the second one out. times the derivative of the first. The derivative of x squared is just 2x. That is the derivative. That's all the calculus there is. But it says express your answer in completely factored form, so I can't leave the answer like this. This is the kind of problem Ms. Barrow would have given you last year in math analysis to factor out everything. Remember, you always factor out the smallest power. So, what are some things that everything has? Well, everything has a 1 minus x squared in it, and the smallest power of that is negative 1/2. And every term has at least an x in it. This will be an x cubed when I multiply it out. That'll be an x to the first. Okay? Let's see what's left inside. This is going to be an x cubed, but I've pulled 1x out, so it's going to be an x squared. The negative here, and the 1/2 and the 2 will cancel. This thing is already on the outside, there's nothing left. Plus, this right here is a positive 1/2, and I factored out a negative 1/2. When you factor out, you subtract. So what's my power going to be? Or you divide, which means you subtract the powers. 1/2 minus negative 1/2 is first power. Whatever's left over will always be a first power, because when you do chain rule, you only subtract one power. I've already pulled the x of this out, so the only thing left here is 2. Again, if you have trouble with this, there's many more examples on Edline. A lot to practice. Let's clean up inside. That's still going to be 1 minus x squared to the negative 1/2, and that's still going to be x. That's going to be negative x squared plus 2 minus 2x squared. So that's 1 minus x squared times x, negative 1/2. What's this going to be? Negative 3x squared plus 2. Now clean up your final answer. F prime equals. Anything that's a negative power goes on bottom. 1/2 is a square root, 1 minus x squared. What's still left on top? It's x, negative 3x squared plus 2. Now somebody's going to say, Mr. Ratliff, can I distribute the x in? Yes, you can, but then it's not factored anymore. What you could do on top if you wanted to is you could pull the negative out, make it negative x, make it 3x squared minus 2. But I don't know that that's any more factored. That's just another way to write the same problem. Whichever way makes sense to you. Be comfortable with problems like this. We're going to spend a lot more time on these. In fact, these are the type of problems that make chain rule factoring or chain rule hard. Again, there's a mini lesson on YouTube dealing with just chain rule factoring. Be able to do the algebra behind it, especially if you did not take Ms. Baer's class last year. As always, if you have any questions, come see me before school, after school, or during study hall. Thanks, everyone.